Welcome to our session on data collection, cleaning, and preparation, which are crucial for any successful data analysis project. These foundational steps are truly essential to ensure you have reliable and accurate data for meaningful insights. Let us begin by understanding the core data types that form the very foundation of data analytics. Knowing these types is key to effectively managing and processing any dataset you encounter. First, we have structured data, which is highly organized and follows a predefined format. This data is typically easy to search and manage, as it fits neatly into tables and schemas. Next, we consider unstructured data, which lacks a predefined format, making it more complex. This type includes varied information like text, images, or videos requiring advanced processing techniques. Let's explore the key differences between various data formats, which is crucial for effective data management. We will specifically compare structured and unstructured data to understand their unique characteristics and uses. We'll begin by looking at the features that distinguish these data types, providing a clear comparison. First, consider the format, which refers to how the data is organized and presented. Next, we'll examine how each type of data is typically stored, considering different database options. We will also discuss the ease of use, including how simple it is to manage and analyze the data. Finally, let's explore the specific processing tools and technologies best suited for each data format. Now, let's focus on the characteristics and attributes of structured data in our comparison. Structured data is typically organized into predefined rows and columns, like in a traditional spreadsheet or database. This data is commonly stored in relational databases, which use SQL for efficient querying and management. Structured data is generally easy to store, manage, and analyze using conventional data tools. Tools like SQL, Excel, R, and Python, especially with the Pandas library, are ideal for this. Moving on, let's consider unstructured data, which presents a different set of characteristics. Unstructured data lacks a specific format and can include various types, such as text, audio, or video files. It's often stored in non-relational databases, also known as NoSQL databases, or within file systems. Analyzing unstructured data is more challenging, often requiring advanced techniques like natural language processing. Tools such as Hadoop, NoSQL databases, artificial intelligence, and machine learning are used for this. Let us now explore diverse data collection methods, which are essential for gathering raw material for analysis. Each method plays a unique role in acquiring the necessary information for your projects. Surveys are a traditional method for directly collecting primary data from respondents. This involves gathering opinions, feedback, and behaviors directly from your target audience. Web scraping involves automatically extracting large amounts of data from various websites. Automated tools and scripts are used to gather information like product prices or customer reviews. APIs allow different software systems to communicate and exchange data in structured formats. This enables real-time access to reliable data from external platforms and services. IoT data comes from continuous streams generated by interconnected smart devices. These devices, like sensors or wearables, provide real-time insights into various processes. CRM data comprises customer information stored in relationship management systems. This data helps businesses manage customer interactions, sales, and marketing efforts effectively. Today, we will explore the critical process of data cleaning, a fundamental step in data preparation. This involves identifying and rectifying various inconsistencies within our data to ensure its quality. A common issue we encounter is missing data, which refers to incomplete or absent entries. These are records that contain empty or null values, indicating incomplete information in our dataset. Missing data can often arise from various data collection errors or simply from non-responses. Another challenge is duplicate data, where identical records appear multiple times. These are identical records that are unintentionally repeated within the dataset, creating redundancy. Duplicates can inflate the dataset size, leading to distorted analysis and unreliable results. Outliers are extreme values that deviate significantly from the general pattern of the data. They represent extreme values that do not fit the overall general pattern or distribution of the dataset. Outliers can significantly distort statistical analysis and impact the accuracy of predictive models. Finally, we often face inconsistent data, which lacks uniformity in format or units. This refers to data that has varying formats or different units of measurement like yes versus y. Inconsistent data requires careful standardization to ensure uniformity and reliable analysis. Let us now discuss core data cleaning techniques, which are methods for significantly improving data quality. These techniques are vital for transforming raw data into a reliable and usable format. Handling missing data is a crucial step to ensure the completeness of your dataset. Deletion involves removing rows or columns that have only a minimal number of missing values. Imputation replaces missing values with estimated figures such as the mean, median, or mode. Predictive imputation uses advanced models to forecast and fill in any missing data points. Removing duplicates is essential to maintain the integrity and accuracy of your data. We identify and then remove exact duplicate rows to ensure each record is unique. Sometimes, entries with slight variations need to be merged into a single, consistent record. Standardizing data ensures uniformity across all entries, making it easier to analyze. Case normalization involves converting text to a consistent case, like all lowercase, for uniformity. Unit conversion is vital to ensure all units, such as currency or temperature, are uniform. Data mapping corrects inconsistent labels by linking them to standard, predefined categories. Let us move on to data pre-processing steps, which involve transforming raw data for effective analysis. These steps are crucial for preparing your clean data for machine learning models and further insights. Encoding categorical variables involves converting non-numerical categories into numerical formats for models. This transformation allows machine learning algorithms to process qualitative data effectively. Feature engineering is the process of creating new, more informative variables from existing data. These new features can significantly improve the performance and accuracy of your models. Data partitioning means splitting your dataset into training and testing sets for model evaluation. This ensures that your model is tested on unseen data to assess its generalization ability. Handling imbalanced data involves adjusting class distribution to prevent model bias. This ensures that your model does not unfairly favor the majority class in predictions. Dimensionality reduction aims to reduce the number of features while retaining essential information. This simplifies models. Let's now discuss various methods for effectively handling outliers in our datasets. This involves identifying and systematically addressing extreme data points that can skew our analysis. One straightforward approach is visual detection, using graphical representations to spot outliers. We can use box plots, scatter plots, or histograms to visually identify data points that stand out. These plots visually highlight data points that fall significantly outside the expected interquartile range. Another powerful technique is the z-score method, which quantifies how far a data point is from the mean. This method measures the number of standard deviations a particular data point is away from the mean. Data points with a z-score greater than 3 or less than -3 are typically considered outliers. The formula for the z-score is z equals x minus mu divided by sigma. The interquartile range, or IQR method, is another effective way to detect outliers. This method identifies outliers by analyzing their position relative to the dataset's quartiles. Values below Q1 minus 1.5 times IQR or above Q3 plus 1.5 times IQR are outliers. The IQR itself is calculated as Q3 minus Q1. Let us now look at Python for data cleaning with practical code examples using the Pandas library. Python offers powerful tools to efficiently clean and prepare your datasets. We begin by loading data into a Pandas data frame, which is essential for manipulation and analysis. The Pandas library provides functions like readxv and readexcel to easily import your datasets. You can load data using Pandas. For example, by importing Pandas as PD, then reading a CSV or Excel file. Identifying and handling missing data is a critical step in ensuring data quality. You can detect missing values, drop rows, or fill them using various methods like mean or median. The code demonstrates checking for null values, dropping rows, and filling missing values with the column's mean. Removing duplicates is important to avoid skewed results and ensure data integrity. The drop duplicates method efficiently removes any identical rows from your data frame. Here, dfNoDuplicates is created by calling the dropDuplicates method on the original data frame. Moving on, we will explore Python for outlier handling and transformations using step-by-step methods. These techniques are vital for refining your data and preparing it for robust analysis. First, we calculate z-scores for numerical columns to identify how far data points are from the mean. The code imports z-score from SciPy stats and applies it to selected numerical columns. Next, we identify and filter out outliers from the dataset using the calculated z-scores. This step removes data points that fall outside the typical range based on a z-score threshold. Then, we calculate the interquartile range or IQR values for specific columns. This involves finding the first and third quartiles, then subtracting Q1 from Q3. Finally, we filter the data based on the IQR to effectively remove any remaining outliers. This ensures our dataset contains only values within the acceptable range defined by the IQR. To summarize our discussion, let us review the key takeaways you should remember. These points highlight the most important concepts from our session on data preparation. Understanding data types, both structured and unstructured, is absolutely foundational for effective analysis. Remember that diverse collection methods like surveys, APIS, and IoT suit different data needs. Data cleaning is essential for addressing missing values, duplicates, and various inconsistencies. Pre-processing your data thoroughly prepares it for building robust machine learning models. Both Python and Excel offer powerful tools for efficiently cleaning and transforming datasets. Proper handling of outliers and missing data is critical for ensuring reliable and accurate analysis.